Thank you, Lydia, for the kind words of introduction. Thanks a lot for joining our today's webinar. My name is Nikolai Garcia. I'm an applications engineer at MPS Power Module product line. The topic of today's webinar is going to be the power modules that are suitable for drone applications. But before we get to that, I'd like to give a little introduction to the MPS as a company. So MPS, which is a Monolithic Power Systems, is a company that was founded in the United States, with a headquarters also located in the United States, and as you can see in the slide, with a global presence in Europe, United States, and Asia. I'm based in Barcelona office, where we have a very large and the largest European research and development center. In addition to that, we have evaluation, EMC facilities, and other labs located in Asia, United States, and Europe. So as you can see, our global presence is very wide and we can cover all the time zones, which is very helpful when working with the customers. Talking about the MPS product families, the portfolio of products is very large. You can check it yourself after the webinar on our main page with the product section of the top bar menu. It ranges from AC to DC power conversion, DC to DC converters, solutions for AI and compute power, power modules, of course, battery management, and so down the line. The portfolio is very large, and you can easily find the application, the solution for your application. The topic of today's discussion is going to be the drone applications. We already see a lot that the drones are getting more and more popular, not only in the videography type of applications, but for surveillance, deliveries, terrain scanning, mapping, communications, and the list of potential areas of usage just goes on. So what is really important to understand here is what stands behind the power when we're talking about the drone applications. How does the power comes from one end to another? And in addition to that, when designing the system for the drone application, we need to work closely with the main constraints that are happening when designing the power circuitry and the power solution for the system. This includes operating in a space-constrained environment, the demand for very high efficiency, the necessity of design simplicity, very good thermal and EMC performance, and then one of the main important topics here also is the FPGA power requirements, because we know that nowadays a lot of signal processing is happening, a lot of commands require a lot of compute power, so the FPGAs are being the main kind of control unit of modern drone applications. So today we're going to start with the space constraints. Space constraints is a subject that kind of goes side by side with a drone application, because we need to make drones smaller, more advanced. We need to integrate a lot of components inside a very dense environment, and that's where the power modules came to stage. First of all, talking about the power modules in MPS and in Power Modules product line, we are talking about the solutions that integrate the inductor and the power stage in one package. So what we are doing is we're taking the silicon die, which we call the MPS power stage, and then we place an inductor on top or side by side, integrating it all together, so you get, let's say, sort of a plug and play device that you can just populate on your board, and it just goes with it. So we have two separate ways how we're creating the power modules. First, we can do is to have an open frame module, and another way is to have an overmolded compound. The main difference is that open frame, you can physically see the inductor being populated on top of the silicon, and the overmolded compound would just look like a casual brick to you. Then when it comes to the space saving can come from two different directions. First of all is the compact device package. Second is the minimum solution size. Both topics are really important. If we want to address the compact device package, we can take a look as an example on the series of NPM 38, 16, 26, 36, and 46C modules. Those are pin-to-pin within the family products that are available in ultra-compact 2 by 2.2 millimeter package. which is extremely tiny. It's really hard to see with your own eyes. Using these devices, you can achieve up to 4 amps of continuous current, and the current goes from 1, 2, 3, or 4 amps respectively, depending on the part number. It comes with a constant on-time control that allows the fast transit response, and you need the minimum amount of external components to use these products. They're extremely tiny, and this is how we achieve the compact package solution. Another way how we can save space is to minimize the total area you're going to be using. So here what you can see is the actual comparison between the discrete solution and the PMIC module solution. Both are doing the same functionality. Both are quad output solutions. But when we are working with the PMIC power module, what we are doing is we are integrating 4 inductors and controller inside single package, and you'll still have 4 outputs, but the total area you require for this kind of application is reduced by up to 80%, so to speak, which is around 125 millimeters squared. While working with a traditional PMIC solution, we are looking at around 690 millimeters squared. So it's a considerable change in your total design, the area required for your design. The part that we're talking here is the MPM 54304 PMIC module. It comes in a 7x7 package, so very compact size, and it comes with all the features that we integrate in our devices. For example, the I2C interface that allows you to read back the telemetry and program the part, set the output voltage, change the configuration. For example, this part is a quad output, but you can easily configure the channels to be paralleled and achieve higher output power if your application requires such a thing. And this is also comes with a lot of integrated protection features to, let's say, maintain and achieve reliable operations of your application. The next topic is efficiency. Efficiency is a crucial thing when working with drones, because efficiency is a parameter that kind of helps to increase the drone productivity, because we know that mostly the drones are powered by the batteries. This could be 24-volt batteries, 36-volt batteries, and up to 60-volt of batteries can be used to power modern drones. Then these battery packs provide the voltage to the main first initial conversion stage that then steps down the voltage that goes to the main control board. This is where efficiency is very crucial, because this conversion is absolutely necessary to kind of maintain the correct operation of the system. And MPS Power Module team has several products that are perfect for this kind of applications. For example, we can take a look at the MPM 3519. MPM 3519 is a single output, fully integrated power module. That means the inductor is integrated into the package that allows you to operate with the input voltage range of up to 36 volts. So it is great for 24-volt batteries. And then your output can be configured from 0.6 to 12 volts with up to 10 amps of continuous current. What is also great about this part is this: you can multi-phase several chips together and provide even more power for more power-hungry applications. What is also great is the package size, because it's still 7x7 millimeters with 4.4 millimeters of height. All of this comes together with a very high efficiency at the output. Depending on the input condition, we are ranging from 90 to 95% efficiency at the peak load of 10 amps. When I'm saying 95% efficiency, it's important to understand what are we placing behind this number, because on the one hand, I can give you a number of 95%. On the other hand, how can you trust my measurement? So that is why MPS and MPS Power Modules team are taking the testing seriously. So we have our test approach that includes, first of all, using automated test scripts. This way we eliminate the human error and the human factor inside the capturing the data. So kind of verifying that our measurements are absolutely correct and everything is sharp. The second important thing when taking the efficiency measurement into account is apples-to-apples testing. A little bit about the apples-to-apples testing. Apples-to-apples testing is very important since we cannot simply compare part to part without taking into account different test environments, temperature, design, let's say, layout, the equipment we're using to gather the data, cables, and so down and so forth. The list goes on. So that's why when we are testing our products, we have strict rules that we are following for each efficiency measurement in particular. First of all, it has to come with identical test conditions. That means ambient temperature should be at the same level. We usually do this with an applied cooling fan, so we have the part cooled. If you take multiple measurements, this is a great advantage because you maintain the same temperature. Airflow speed, as I already mentioned, we're using the fan with the same airflow speed, so it is in a controlled environment. And if there is no airflow while the measurement is being conducted, we also make a note for that. Test environment, very important. We are testing in the same lab environments. For the efficiency case, this is not that detrimental, but if measuring the noise, for example, the lab environment has to be the same, so the noise floor level needs to be maintained the same. The next point in the apples-to-apples testing is the test equipment. Of course, we can say that using the generic power supply, DC load, and DMM can be okay, but then each manufacturer has a little variation. Each device has different remote sense. Each device has different, let's say, threshold for certain parameters. So what we need to do is to maintain a precise measurement is to have a calibrated test equipment. And the test equipment has to be consistent throughout all the measurements we're taking. This includes the power supplies, the electronic loads, and the multimeters we're using. Plus, what is also very important is the cables, because of course cables can inject the voltage drops and parasitics. That's why in MPS we've developed our custom twisted pair cables with Kelvin connections. And in addition to that, all of the tools we're using, the test equipment we're using, has the remote send connection coming directly to the board. And if we're testing one of our products on the AVB, we'll find the test pins directly for the remote sense, so the equipment can compensate itself. So all of this comes together for the apples-to-apples testing. And then coming back to the standardized kind of format, if we want to compare and contrast several products within the same family, we need the data to be in the same format with the same grid lines. And that's what we are also doing in the Power Modules team. So all of our data plots are identical and provide reliable data to our customers. The next topic is design simplicity. Design simplicity is very important because designing a drone can be a very challenging task itself. So we, as a provider of power and as an expert in power, want you to spend as less time on designing a power stage as possible. So if you remember the diagram we touched at the beginning, that was coming from the primary battery pack to the main control board. Here we are kind of diving a little deeper into board level. And as you can see, coming from the battery pack, we also see a lot of DC to DC stages, because modern applications have communication modules, GPS modules, gimbals, motor drivers, FPGAs, microcontrollers, and the more sophisticated your application is, the more power you need, the more power converters you have, less space you have, and less time you have. So when working with MPS Power Modules like the PMIC Power Modules, we provide a very compact solution and simplify the design as much as we can. For example, working with the MPM 54524, which is an 8x8 by 2.9 millimeter solution size device, allows you to have up to 4 channels at the output, with each channel being capable of delivering up to 5 amps of continuous current. It also includes the interface for I2C communication, which then subsequently allows you to configure the parts, configure the output voltage and different parameters of the part, like the soft start and then like the power good delays. You can merge 2 channels or 3 channels into one to provide higher power if you need. And then using the PMIC power modules allows you to use single part number and provide power for many targeted areas of your, let's say, board application in the drone segment. You can use 20 amps from 4 channels parallel for the core rail of your FPGA, for example. And again, this is great because it also comes in the 8x8 millimeter package and provides the output voltage on a very high efficiency level. I've mentioned the PM bus interface and the connection that you can establish with the device by using it. What you can also do to simplify the design is to use the VirtualBench 4 tool. VirtualBench 4 is the guided user interface that we developed in-house. It allows you to configure and program the parts using the I2C dongle that we also provide on your machine in the lab. You just get the guided user interface. It's free to download at our website, and then you get the tools to operate with MPS devices. So for instance, what you can do is you can set up the parameters, you can read back the telemetry, meaning you can get the data about the input voltage, the output current, and the temperature in a numerical format or the waveforms of the main signal. You can evaluate the device in the offline mode, and then also what is very good about working with the VirtualBench, you can save the configuration when you are, let's say, certain that this is going to be your configuration for your system, export your settings, contact your MPS representative, and then we can create a custom part number suffix for you with your configuration. That means when you order the part and it arrives, the only thing you need to do is just plug and play it on your PCB, and it will be pre-programmed with already with the parameters you've pre-selected before when you were doing the evaluation and prototyping. So this kind of sums up into fast time to market and fast evaluation kind of thing. Here, what I am demonstrating to you is how actually easy it is to program parameters using the VirtualBench. So for example, if you want to program the soft start delay with one of our PMIC modules, we just launch the tool, scan for connected devices, add the device that comes from the part number list, and then for the required buck output, we just check the power on off menu where we can see what are we changing. Here it says soft start delay, so we set the soft start delay to the desired value, and then the only thing we need to do is to first save it to the volatile memory, read it back to ensure that everything is saved correctly, and then we can save it to the non-volatile memory. After that, we perform a power cycle and the changes are automatically applied. So what I did in the video is I changed the soft start delay from 0 milliseconds for both channels to 1 millisecond for channel 1 and 3 milliseconds for channel 2, respectively. After the power cycle is performed, we can see that the changes are already being implemented. So it took me less than 20 seconds to change some of the parameters very fast. The next topic here is the thermals and the EMC testing. The thermals are crucial for this kind of applications because drones are kind of sealed in devices, so the temperature inside rarely has airflow, or if it does, it is always changing depending on the speed. In addition to that, the temperature outside the drone changes dramatically because of the, let's say, altitude change. So you can start at 25 degrees Celsius and go way above 3,000 feet and get to negative temperatures. So to be able to evaluate what do we need, MPS has a very great set of tools we can use and facilities we can use. We have several labs located in each part of the world. This includes the EMI-MC lab in Detroit, EMI and AMC facility in Ettenheim, Germany, and in Hangzhou, China. There, what we can do is provide test reports to our customers upon the request, and when developing the products, we also perform a lot of testing of our parts. So this kind of spins around the MPS quality policy. So what we're capable of doing is running the EMC testing for different type of standards you may be looking at. It can be the CISPR emissions, CISPR immunity for industrial, scientific, automotive applications, and so down the line. Then what we are also able to provide is quality reports. Quality is very important, especially when working with drone applications. So for instance, the tests like thermal shock or vibration testing are very necessary to evaluate the correct performance. We can do that. Solder strength and soldering guidelines for our products are also available. And then the list of tests goes on. What is also great is that we're testing our products prior releasing for the full qualification. So when you're reaching out to MPS, we might already have the results for the products and we can provide them straight away. Otherwise, if you're working with a specific environment, specific condition, and you're looking for some specific graph, we can do this test for you. This will result in very transparent environment with our customers. The other topic here would be the temperature testing. As I already said, the temperature is a sensitive topic working with drones. So to do that, first of all the power modules are industrial qualified. So that means they operate from -40 to 125 degrees Celsius. And to evaluate this performance, we have three different tools being used. Thermal chambers with a thermal shock capability, and we've developed our custom chamber. It's called the thermal wind tunnel. That's where we can control the flow and the speed of the air, including the temperature of the air, and we can change the different angles, how the airflow attacks the cooling, and how the part is being positioned inside the case. So we can evaluate all of these parameters that helps to provide the most kind of accurate data of the performance we get. A little other introduction to the MPS lab facilities. So we have different chambers. It's the CISPR chamber, the shielded chamber, electrical and pulse testing, and we can also run the test for our customers when they need, upon the individual request, of course. The other important topic is the thermals. So when designing the parts, we can essentially split the thermal part into two different kind of segments. First is going to be the simulation part and then the actual part. So starting with simulation, when developing new products and working with our products, we run very, let's say, deep simulations of our parts to see how the part is reacting. Our simulation team is doing an excellent job while developing the iSpec models and flow therm models, so we can see how the heat is being distributed on the board, and then we can get the preliminary data for our thermal resistance and thermal characterization parameters. Then what we also need to do is when the product is actually developed and released, we do the test on our board in the lab, so we can see that the theoretical simulation results are actually matching the results that we can see in the lab. And only after that, we are finalizing the datasheets and we're providing everything that we can for the absolute transparency of our products. So to quickly summarize the Power Module testing and MPS testing capabilities is we take tests seriously. Testing is very important and we are concentrating our attention around how we are doing this. We are running efficiency tests, different conditions, different specs of the parts. We are running EMI radiation and immunity, D ratings, thermal shocks, FFT noise measurements, and the list goes on. And if the customer requires for any specific measurements to be taken, we can also do that upon the individual request, of course. Another topic that we are covering and that I've kind of briefly mentioned at the beginning is the voltage regulation. So drones operated by and controlled by the logic boards that usually include the FPGAs and microcontrollers, but mainly FPGAs. So when working with FPGAs, it's important to take into account several things. Voltage accuracy, and the FPGAs might have several rails, and some of those rails can be high current rails. So here we also split the power tree into two stages. First stage would be our primary stage, where we go from 36 volts to 12 or 5, or from 48 volts to 3.3. And then what we do is we pass it to the second stage, where another set of power modules regulate the voltage further on to 0.8 volts, 1.2 volts, 0.9 volts, and so down the line, depending on the specification of the specific FPGA. Using power modules is great here because power modules provide high power density. So in a very small package, you get up to 50 amps, up to 40 amps, and then the devices can be stacked together to provide even more current if needed. And in addition to that, MPS has a very good reference design team working constantly by updating the reference designs we have for modern FPGAs currently available at the market. So what you can expect to find at the FPGA section of our website is actual designs that are being developed in partnership and approved with the major FPGA manufacturers such as Xilinx or Altera or Lattice and so down the line. And we also can categorize them there. So you can find the lowest cost, you can find the smallest solution size, you can find the highest efficiency reference design. This also helps you not only to see which products, let's say, are already approved by the manufacturer of the FPGA, but also how easy it is for you to get the design because we already did this part for you. And then, since I was saying the voltage regulation, modern FPGAs require plus minus 3% for the core and transceiver voltage rails. Our auxiliary go from plus minus 5% respectively, but we see this trend that the tolerance is getting tighter and tighter. So we need to be able to comfortably develop products that will supply this plus minus 3% tolerance voltage. So for instance, NPM 3696 that can be used for the core power of the FPGA because it can provide up to 40 amps of continuous current with the wide input operating voltage range and wide output operating voltage range at very high efficiency and is capable of stacking and available in a small package with 7 by 7 millimeters respectively. Why it is great for the FPGAs is because it implements MPS proprietary ultra-fast constant on-time control. Some words about the constant on-time control. If we compare constant on-time control with the industry standard peak current mode control, there is a big advantage that we see. As we already mentioned, the FPGA, they are very intolerant to the voltage drops. So we need to be able to provide the stable voltage even with a transient that can happen very fast. So in the peak current mode control, if the low step happens without the sync to the switching frequency, we cannot deliver the power until the next switching cycle comes. So we need to wait this one clock period, let's say. When this happens, what we can see is the output voltage actually drops below the threshold because this energy, it just doesn't come from anywhere. It discharges the capacitors. So we need to recharge the capacitors, and it actually results in a very slow reaction time to the transient change. When we are working with a constant on-time control, what we are doing is we're constantly checking the output voltage. And if we see that the voltage drops below the certain threshold, we inject multiple pulses with a, let's say, fixed time duration that allow us to quickly react to the load change. And in addition to that, we do not discharge the capacitors, so we stay within the tolerance. So for example, if we take a look at the NPM 3696-40 ripple response, in the steady state with continuous current, we're able to work within required 3%, and even with a transient, the reaction time is very fast, and it also stays within plus minus 3% of the output voltage, peak to peak. Then the key advantage here is we can reduce the amount of output capacitance. We have the fast transient response. It's stable and works great with the rails of FPGA, available in a small package, has telemetry, and all the previous advantages that I've mentioned before. To summarize, drone applications have 5 key things that we need to take into account. Using power modules can be meant when we're talking about power in drone applications, because it helps easily overcome all these main concerns we're talking about. Space constraints, yes, we integrate inductor and the power stage and some passive components inside single package, saving a lot of space, not only by just having a small package, but also by the overall area you need to use. High efficiency. With MPS testing capabilities, we're able to test our parts significantly with different specifications that allows you to operate at the highest efficiency possible with different, let's say, load. Design simplicity. Virtual bench and PMIC power modules are very simple and easy to integrate in your designs, provide versatile amount of outputs, so you can configure 4 rails, 2 rails, and so down the line, depending on your application. Thermal and AMC. MPS facilities gives, let's say, wide resource of doing the test for the customers and doing the test prior releasing the product, so the results are going to be available upon the request, and if they are already being done in the datasheet. And FPGA power requirements, working with the reference design team and modern FPGA manufacturers helps us to develop products that are better in providing power for the FPGA rails specifically. Some words about the MPS Now. MPS Now is the team of engineers that are helping to solve day-to-day questions with all the MPS parts, not only the modules. If there are any questions related to any kind of part, including the power modules, feel free to reach out to the MPS Now through the link that you can see on this slide. It will be automatically distributed to the country where you're sending this request from, and you can ask any question about any product, and our engineers are here to help you.